Set up your problem. We've got two patterns of dots. These patterns are called pattern 1 and pattern 2. And what your job is to do for number 1 is to explain the visual. How do you see it changing? So we are going to be looking at numbers of dots and stuff, but what are you seeing happen? The visual. Okay? And then you're going to explain how you'd find the number of the 5th step and then complete the table. Note on your notes, that table isn't until the next page. So don't just finish your page. Finish everything that you see on my slide here. You'll have to flip a page, okay? Get after it with your partner, please. So I'm interested in hearing someone explain how they saw pattern 1 changing. Just not numbers, like what are you seeing as the change for pattern 1? Oh, I'm going to pick something random this time, I'm thinking. Yeah. What are you seeing?
For pattern 1.
Yeah, pattern 1.
It adds
Adds 2. And where do you see those 2 being added, or how do you see them being added?
to the right side.
To the right. So that's what I saw. I see them being added onto that right side over and over. Someone else earlier today saw that bottom right one staying the same, and they saw these being added each time. It's the same thing. It's adding 2 each time, right? So someone else today saw that bottom right stay the same. So yeah, it's adding 2 each time. So what about pattern 2? Correct? Okay, I'm listening.
The guys increasing by 2 each time. So it goes from 1 to 4, which means it's increasing by 3, and then it increases by 5.
Okay. So what do you notice about, how would you explain how the shape is changing? Other than just numbers.
It's kind of like expanded. It's heightened it.
Expand the height and width by how much each time? 1 in both directions, right? If it's a thing time, so let's say it's changing by x. To get area, it's changing by that value squared. So that's what I saw. I saw each step creating 1 dimension of my square. Anybody else see that? Some other people today saw something like an L pattern getting added each time. And the previous was always the previous step. Step 0 would be 0 squared. Yeah, so I saw it being squared, but did you guys kind of see that other thing I drew? That's not how I saw it, but that's how it was. So to find the 5th, what most people have been saying for pattern 1 is I'm starting with 1, and then I'm increasing by 2 5 times. So how many for the 5th? 11. Anybody else see that? Okay. So we had 1, 3, 5, 7, 9, 11. So for the nth term, I would say 2 per each term plus 1. We kind of figured that out up here, right? I was adding 2 over and over. That constant rate of change tells me that this is what type of function? Linear. Linear. That starts at 1. Okay. Now to find the 5th, what's happening over here? Well, 0 squared, we squared it. We're always squaring it. So to find the 5th, what's 5 squared? 25. The 5th would be 25. It's right here. Okay. And then for the nth term, what would I do for my nth term then? Square. Just square, right? So the question here that I'm going to have you look at in just a moment is what type of function is this? One thing that you're going to use to help with that is, next in your notes packet, there are a couple graphs for you to look at. So you're going to make the graph and look at them. Everybody see that? Raise your hand if you don't see it on your notes packet. It should be underneath the table. You got it, Vinny? Yeah. Okay. Awesome. So let's see what they look like next. All right, so to graph that first one, the 0 term started at 1. So 1 was 3, 2 was 5, 7, 9, 11, 13. Continuous or discrete? It's worth having the conversation. Do we have partial dots? Maybe in theory. But for dots, it's just that number of dots a little bit too. So I'm going to choose not to make it continuous. I'd say, this one had this many dots, this one had, there's no dots in between dots. Unless we talk partial dots, but then, I don't know, how do you count a partial dot? Wouldn't it just be a little dot?
That's what I did. I did dots.
Okay, so pattern 2, I'm squaring it. 0, 1, 4, 9, 16, 25, 36, something like that. Okay, there we go. So, who can explain to me why pattern 1's graph looks like it does? Why does it look like that? Maybe some features. Maddie? So yeah, constant rate of 2. And then what else? It could be like a bunch of places with a constant rate of 2, right? Why is it where it is? There's lots of different lines that have a constant rate of change of 2 or slope of 2. Yeah, right. The starting point of the y-intercept right there is 1, right? So I'd also maybe point out y-intercept of 1. Because if it's got a different y-intercept, it's a different line, same rate of change, right? Okay, pattern 2. What's happening there? Vinny? Everything's getting squared over and over, right? And what might we be tempted to think type of function that is? We'd be tempted. It looks very exponential. Would you agree? Have you seen them kind of curve up? I would agree. But an exponential function has a common factor, right? And our outputs went 0, 1, 4, 9, 16, and so on. Is there a common factor from my outputs here? Like let's say we said 1 to 4, that's times 4. Is 4 times 4 9? So we don't have a common factor. And let's look at another thing. This is just n squared, right? When we had an exponential function, where was our variable? It was in the exponent. Where's my variable here? The base of an exponent, right? So let's also be mindful my exponent is 2. I want to point that out. And here's another thing I want to point out. And I don't remember if I showed you this or not. Let me actually grab this to move this. I'm going to give myself some more room there. Okay. So, check out. I'm going to write the differences here. This is just kind of a fun thing. Would you agree those are the differences from one to the next? Check out the difference of my differences. The difference of the differences is always 2 in this case. That's kind of cool, I think. Now, one more visual I want to show you. This only shows quadrant 1, which again looks like an exponential. And if it were exponential and I connected things, it would go like this, right? Would I actually get to 0 with an exponential? No, because there's always a little chunk, right? So that's one reason we know. Another reason we know is that let's theoretically extend this to 4 quadrants. If I input -2 for my input, what does it pump out? 4, positive or negative? Positive 4. So that means, let's say -5. If I put in a -5, it's going to pump out a positive 25, which means there's a mirror image over here as over there. I know that doesn't look like a mirror image, but there's a mirror image thing going on where now if we see the whole thing, does that look exponential? No. So this one is not exponential, not linear. It is quadratic. Next pattern of squares. Again, you're going to start by explaining how you see it changing. You're going to complete your table, and then you're going to say, is it growing exponentially, and how you know that it is or is not. So start by explaining the visual. On this one especially, I find the visual really helps that end term. Who can explain to me what they see as they look at this pattern progression? What's the visual? How do you see one change to the next? Yeah, Sean?
It goes up by one row and then one block at the end.
So like last time, up 1 row and 1 width. Okay. So the easiest way is maybe draw. I see this portion being what changes. 1 by 1 to 2 by 2 to 3 by 3.
Yeah.
Is everybody seeing that?
Yeah.
Okay, so that portion that I circled is kind of like the previous one that we had n squared. Would we all agree? And then what's happening? What else is on each one of those?
Add 2.
Just plus 2, a constant of 2. Every time there's just those 2 extra. So I got the square in the middle and then the 2 extra every time. That's n squared plus 2. And n is the step number each time. So for step 1, 1 squared is 1 plus 2 is 3. And we can count 3 there, right? For the 2, 2 squared is 4 plus 2 is 6. 3 squared is 9 plus 2, 11. 4 squared, 16 plus 2, 18. 5 squared plus 2 is 27. 102 and 146. I want to check out that second differences thing. You guys think it's going to work? The second difference
I
again?
think so.
Let's check it out. So it goes 3, 5, 7, 9. Holy smokes. The second difference is 2 again. Kind of cool, I think. The difference of the difference. So, growing linearly? Is it growing linearly? No. How do we know?
It's not going up by the same amount.
Yeah, there's no constant rate of change or slope, right? There's no repeated addition. How about exponentially? No. To be exponential, what does it have in common? Or how does it change? No factor. So no growth or decay factor. It is plus 3. It's to get 3 to 6 you could double, right? But then next, if I doubled 6, it'd have to be 12, and that's not there. All right. Cool? I think it is kind of cool. We got a whole new function now. Quadratic function. Soldier Boy's favorite.